And the way I like to kind of introduce radians is, well, straight from this idea of the circumference of a circle equaling 2 times pi times the radius. Okay? 2 times pi times the radius. All right? So the circumference is one way we kind of measure going around the outside of a circle. Right? But you can also kind of measure going around a circle using degrees as well. Right? How many degrees does it take to go around the outside of a circle? 360 degrees, right? If you do a 360, that means you turn around and face the exact same way you were before. So another idea we could say, instead of the circumference being 2 pi r, you could say that 360 degrees, right, is in the same kind of sense equal to 2 pi radiuses, or radii. Okay? And a similar kind of idea. 2 pi radii goes around the outside of a circle. 360 degrees goes on the outside of a circle. Okay? And this is where the idea of then a radian comes in. Okay? 360 degrees is therefore 2 pi radians, this new unit, or not new, again, a unit measure you've seen before, okay, most likely in algebra 2. Potentially even geometry. I think there's like a topic in geometry too. But this is kind of where that idea comes from, okay? The idea that the circumference is 2 pi radiuses around the outside of the circle. 360 degrees is also a full, rotate, or full kind of measure around the outside, or around a circle. And so then we want to equate these two things. All right? And so we have two different units to measure essentially the same thing. The fraction, the part of a circle, okay, or the angle measure, okay. So this is like inches and centimeters, right? Or think like miles and kilometers. It's just two different ways of measuring things. Degrees, radians, two different units, okay. Degrees refers to the idea that it's 360 to go around the outside of a circle. Radians is how many radiuses you're kind of traveling, or what fraction of number of radiuses to fill in that angle if you make the circle. Okay. So from this relationship, we can come up with other degree measures. So for example, if 360 degrees is equal to 2 pi radians, then what would 180 degrees have to be? What's that? Pi. Yeah, no, that's right. It's pi. How'd you get that? You just remember it from before? You just said it and you just mathemagicked it up. Okay. Why should that be so? Divided by 2, right? It's a proportional relationship. So 360 divided by 2 is 180. So simultaneously, 2 pi divided by 2 should be pi, right? If this is an equation, we should be able to divide both sides by 2. And so they can say further then that like 90 degrees would be what? What radian measure would that have to be? Pi halves, or 1/2 pi, or pi over 2, whatever you want to say there. So yeah, like we can write it like this. Okay, 1/2 pi, or pi over 2, like that. Radians. Okay. So again, that means if you take a radius of the circle, okay, and you multiply by pi over 2, that will be that measurement along the outside of the circle that will get you a 90-degree angle. Pi halves of a radian. Okay, pi halves of a radian. All right, and we can keep going, right? We could go halves again, right? So like 45 degrees, for example. What would that be? What? I heard it. Pi over 4, right? Or 1/4 pi. Radians. Okay. And so on and so forth, right? So we could like just come up with like different scales here. And we'll talk a little bit later about converting from degrees to radians and radians to degrees, right? But I just wanted to start with basic ideas about different, angles that we are used to. All right? So let's draw a little circle here and see what kind of measurements that we can kind of come up with on this circle. Okay. I used to have like CDs that I would give out, and you guys would like be able to trace the CDs, but I threw those away. So now I don't have them anymore. So we'll just have to hand draw these circles here. Okay. Something like that. Okay. So this picture may get some of your blood, pumping here, a little sweat on the palms or something like that. You're a little nervous. The unit circle, you're like, we're not going to get quite there yet today, so don't worry, okay? It's going to be okay here, folks. But we are going to start, okay? So, for example, some simple angle measures, right? Here, for example, would be an angle we would say like 0 degrees. So what have I done here? What have I done? I've taken a circle, all right? I've taken that circle and we centered it at the origin. Remember, that was like one of the first topics we ever discussed was the equation of a circle. And one of the first equations of a circle that we discussed was a circle centered at the origin. All right? We're not going to worry about what the radius of this circle is right now. We're not going to worry about other things like sine or cosine right now. We're just talking about angles along this circle. And so when we place a circle here on the coordinate plane, because this is like the x-axis and this is like the y-axis here, x-axis, y-axis, that's why I drew those in. Okay, we measure from this part of the x-axis. Okay, and the angles are always measured in a positive direction, counterclockwise. Okay, so we're going to open up from this x-axis here where we're going to put 0 degrees, or in radians, that'll be 0 radians, right? 0 degrees is 0 radians. And then we'll go counterclockwise around that circle to come up with some more angles. All right, and so let's just go, again, the whole way around would be how many degrees? 360, right, which is 2 pi radians. We got that from our warm-up. Okay. And then we said halfway around, so let's see, instead of going the whole way around, going just halfway around, that was 180, right? 180 degrees, or just pi radians. Okay, that's like halfway around the circle there. And let's see here, we also talked about half of the halfway, so instead of going halfway around, half of that would be to right here, right? We know that's 90 degrees, or pi over 2 radians. Okay, so hello Dave, what's up? Bless you. Yes, I should have one. There you go, sir. Check to see that it turns on. That one actually maybe did, now that I think about it. Here, this one. There you go. Don't want to give you a dead calculator. You're welcome. Okay, so there's 90 degrees, pi over 2 radians. Bless you. So from here to here is 90 degrees, and then if we go a further 90 degrees, right, 90 plus 90 gets us to 180. What is this angle measure here from the 0 all the way around? 270. Very good. Another 90 degrees from that 180. And so then what would be the radian measure here? Well, let's think about this. So you go from here to here, it's pi over 2. Right, here to here, pi over 2. If we go another pi over 2, that's a pi over 2 plus another pi over 2. 1 pi over 2 plus 1 pi over 2 is 2 pi over 2. 2 pi over 2 is just pi. Right, so pi over 2 plus a pi over 2 gets us to pi. And then plus another pi over 2, well, it's going to be 3 pi over 2. Right, to get there, so 3 pi over 2 radians. Okay. You don't need to keep writing the word radians there. Okay, I'll assume that if you're talking about an angle and you don't put a degree symbol, that you're indicating that measures in radians. Okay, if we're talking about angles and you don't put a degree symbol, then I'll assume you're talking about radians, because I don't really know other ways to measure angles besides degrees or radians. So it's not one, it's going to be the other for our purposes at least. All right, let's get a few more angles on here. So for example, we've been doing some halves of things. So let's go half one more again. We already have the 45. So 45 would be halfway to the 90. So something like right here maybe. Okay, so that'd be like 45 degrees, which is then again pi over 4 radians. And the beauty about like continuing to like have things, to cut things in half, is that we can, it's equidistant from our two angles that we know. So if we go pi over 4 here, radians, we're at about 45 degree, or pi over 4 measure. We go another pi over 4, so that's a total of 2 pi over 4 here. 2 pi over 4 simplifies to pi over 2. Okay, so 2 pi over 4, we can then go to here, and that's 3 pi over 4 radians. Right? I'm going to stop writing the word radian now. Which is just another 45 degrees from that 90, so it'll be 135 degrees there. Okay. And so why don't you guys go ahead and try and come up with what angle would go here and here. Again, the halfway points. So what will be the degree measure? What will be the radian measure there? Use your understanding of fractions. So like how many degrees and how many radians based on that. And then same thing here. How many degrees and then how many radians. Okay. Remember, we're going pi over 4 or 45 degrees away there. And pi over 4 or 45 degrees away, or pi over 4 less and 45 degrees less. Okay? Let's take like a minute there and try to figure those out. All right, do we have a volunteer for these two measures here? What would they need to be? If we're going halfway between the 180 and the 270, or halfway between the pi and the 3 pi over 2, what would they have to be? Ooh, okay. Matt, what do you say? 5 pi over 4 and 235. It should be 225. Close. 225, I think, yeah. We add 45 there. But 5 pi over 4 is right. Yes, good. So again, just add a 45, right? We're going 45 degrees away, so 225. Or add a pi over 4 to pi, right? So this is like fractions, right? Pi is 4 pi over 4. Add another pi over 4 to it, you get 5 pi over 4. Okay? And how about this one right here? How about this one right here? What would that be? Whoops, moving around. Yeah, Sean, what do you say? 315 degrees, right? Or 7 pi over 4. Okay? Again, you can think about this 315 a couple different ways. You could go 45 degrees adding to that 270, which gets you 315. You can also go 45 degrees away, back from that 360. So 360 take away 45 also gets you that 315 there too, right? Because it's 45 degrees from here and here. Likewise with the 7 pi over 4, right? Since we're going 45 degrees from here or from here, we can add pi over 4 to 3 pi over 2. Or we can subtract pi over 4 from 2 pi to get that radian measure there. Okay, very good. Questions on any of those? All right, wonderful. So one thing I do want to talk about as well here that kind of pops up is the idea of a coterminal angle, or coterminal angles, I guess I'll say. Because, for example, right here, this very first point that I discussed with you guys, right? This first point here has kind of two measures associated with it, right? This first kind of location, this first kind of angle, has both 0 degrees or 0 radians associated with it, but also 360 degrees and 2 pi radians. This position of this angle, if you start and stop right there, it's 0 degrees, 0 radians, or if you start, go around one full rotation and come right back, you're in the same exact position as you were when you started, so it's again the same kind of idea, same positionally kind of angle. Okay, and so this idea is a coterminal angle, right? So co, right? You've seen that prefix before, it means to like share or something like that. Terminal, right? So terminal means to like end, but it also can mean to start too. Like for example, when you go to an airport, right? You have to locate your terminal. That's both where your journey starts and where your journey ends, because you fly and land at a terminal as well, and you exit the plane at a terminal. So it's both like the starting point and stopping point of something. And so then coterminal angles are angles that share the same starting point and stopping point. Okay. So all the angles on this circle share the same starting point, right? They all are going to share this kind of like side right here, because this is where all of our angles are measured, from this side right here. Okay? But not all of them share the same stopping point, except for this pair that we have listed right here. Okay? How can we find more angles then? So for example, if we have this 45-degree angle here, what could I do to this 45-degree angle to end up in the same exact position as where it is right now? What could we do to find an angle that's in the same exact position as that 45? What was it? Yeah. Do what? Go another way around, right? Add a 360 degrees to this. Right? If I'm at the 45 and I add 360 degrees to it, that's going to get me right back to that 45. And I could do it again. I could add another 360 degrees, and another 360 degrees, and another 360 degrees, right? And so there's actually an infinite number of angles that locate or identify this position here, from here to here, right? There's an infinite number of angles that could identify that same if I just keep adding 360, or I could also subtract 360 as well. I could keep subtracting 360s and I get in the same position, because adding 360, subtracting 360, I'm in the same location. Okay? So, to find coterminal angles for degrees, okay, just add or subtract 360 degrees to your angle measure. Okay? And that will locate a degree in the same exact position, a degree measure that's in the same position as your original one. If for degrees we're supposed to add or subtract 360 degrees, right? Then what do you think the equivalent adding or subtracting would be for radians? Yeah, Devin? Exactly right, right? If 360 degrees is what we add or subtract, then the equivalent radian measure is 2 pi. So we can likewise add or subtract 2 pi for radian measures to get, again, positive or negative coterminal angles and stuff like that. And so that's something we want to be comfortable with, right? Because sometimes we might be given an angle that's just like really large, and we're like unfamiliar with it because it's such a big measurement or something like that. And so we can just then subtract 360 or subtract 2 pi until it's a more familiar kind of angle. All right. For example, we might see something, and let me give you an example here. So let's say we want to give a positive and negative coterminal angle excuse me, for each measure. Okay. And so, let's see here. We might see an angle like 390 degrees. Unfamiliar to us. It's not between the normal, the typical 0 and 360, right? Most of our stuff that we're going to be working with, mostly we'll be working between 0 and 360 degrees. But here it's 390 degrees, right? That's like outside our normal kind of range. But what could we do? Well, we can subtract 360 degrees from this. Okay? So do like a minus 360. And what does that get us? 30. And so evaluating a 390-degree angle, okay, and positionally at least, it's in the same position as a 30-degree angle. Okay? It's in the same position as a 30-degree angle. That's not to say that those two angles are, I guess I'm putting an equal sign there, but we're really just coming up with coterminal angles. I mean, obviously a 390-degree angle is not the exact same thing as a 30-degree angle, but they are in the same position at least. Okay? So there's a positive coterminal angle, but I'm also supposed to come up with a negative coterminal angle here. So how should we try and get a negative one from this point? What should we do? I have a positive one. 30 degrees is, coterminal to that 390. They differ by 360 degrees there. How can we get a negative one, though? A negative angle that's coterminal. What should we do? Any ideas? How can we get a negative one? We have a positive one, 30. Sean? Yeah, subtract another 360. Okay. Which gets us negative 330 degrees. Okay. So going 30 degrees in the counterclockwise direction is equivalent to going negative 330 degrees in the clockwise direction. So a negative angle, all right, that you kind of think about that angle kind of opening up in the clockwise direction. So we had been measuring from here and going counterclockwise, right, the opposite way a clock goes. But if you do a negative angle, then that is clockwise, okay, the normal direction that a clock goes. All right, so that's the idea. All right, so let me give you guys two to try here. So try the same idea here for negative 37 degrees. Okay. And then also try for 7 pi over 6. Okay. Again, find a positive and a negative coterminal angle for each. And yes, I know that negative 37 is already negative. I want you to find another negative one besides the negative 37. Any volunteers for the negative 37 degrees? Give me a positive or a negative coterminal angle there. What do we say for volunteers? Yep. Nick, go ahead. Negative 397 degrees, okay. That's a negative coterminal angle. You want to give me a positive one too, please? 323 degrees. Okay. Any questions on that? All good? Okay. How about the 7 pi over 6? 7 pi over 6. Gotta do some fractions of that one. All right. 19 pi over 6 and negative 5 pi over 6. Those are the closest ones, I would say. Questions on any of those? No? All right. Well, I'll pretend like someone's asking a question here and go over anyway. So 7 pi over 6, right? We're going to have to add or subtract 2 pi, which is the same thing as adding or subtracting 360 degrees. Degree measures, that's radians now. So add or subtract 2 pi, right? So like 7 pi over 6. If I want to add 2 pi to that to get a positive coterminal angle, I can't right now add 7 pi over 6 and 2 pi because we don't have a common denominator, right? So I can say that's the same thing as saying I need to get sixths. So 2 pi is the same thing as 12 pi over 6, right? 12 over 6 divided to 2 would be 2 pi. And now I can combine these things. So 7 pi plus 12 pi, there's the 19 pi. And by a similar argument, we can do the 7 pi over 6 minus then the 12 pi over 6, right? Because subtracting 2 pi would just be that. So 7 take away 12 is negative 5 pi over 6, and you get you that one. Okay? So that would be the idea there. And again, you can add 2 pi as many times as you want to get a coterminal angle. You can subtract as many 2 pi's as you want, right? It doesn't have to be the very first one that you get, right? In fact, if you have like a really large positive angle, you might need to subtract several 360s or several 2 pi's in order to get it to be negative. Okay? If you're looking for a negative coterminal angle. Okay. Questions on any of that? All right. Almost done here. Last thing I want to talk about then is just converting from degrees to radians and radians to degrees. All right. And really there's at least 2 different ways, or 2 kind of like related but different ways of doing this. All right. So converting from degrees to radians, okay, and vice versa. Okay, so one method that I've seen teachers use and students try to, students employ, and if you want to use this method, that's up to you. That's fine. Feel free. Is to take, for example, your like degree measure, okay? Take that degree measure and then multiply by pi over 180, and then that equals the equivalent radian measure. Okay. Take your degree measure, multiply by pi over 180, that gives you your radian measure. And then by, just a little algebra manipulation there, if you have a radian measure and you want to convert to a degree measure, you multiply by 180 over pi. Right. So that's one way to do it. Degrees to radians, bless you, multiply by pi over 180. Radians to degrees, multiply by 180 over pi. Okay. The problem I have with this method is that I always would find myself forgetting whether I should be multiplying by the pi over 180 or the 180 over pi. Okay. And I guess there are ways to figure it out. If you have, your way to remember it, that's cool. That's good. Let me give you another idea here. Okay, and it takes a little bit more work maybe, I don't know. But I like to set up a proportion. I like to at least show you guys the idea of setting up a proportion. Okay, set up a proportion. I forgot the letter A there. Okay. Set up a proportion. So remember, we start with, where do we get this idea of degrees and radians in the very first place, right? We took the idea of circumference equals 2 pi radiuses, 2 pi radii, and we said that equal to that 360 because the idea of a circumference goes around the outside of a circle, the 360 goes around the outside of a circle. So, 360 is a proportional relationship with that 2 pi. Okay. So you start with a degree and radian measure that you know. And then you set it equal to some other degree and radian proportion. Okay. Of course, you don't have to use 360 over 2 pi. You could use 180 over pi. And in fact, 180 over pi is the more common, one to use because it's as simple as it can really get, right? 360 over 2 pi, that technically simplifies to 180 over pi. And so again, you can set that to degrees over radians. Okay, but you can really use any proportion. If you happen to always remember that 9 degrees is the same as pi over 2, then you put 90 over pi over 2. And of course, it's a proportion. You don't have to do 90 over pi over 2. You don't have to do 180 over pi. You can make it pi over 180 if you want to. Right? Setting up a proportion and then cross multiplying, I just find is like, it kind of, in my mind, it takes some of the memorization out, I guess. But again, it's up to you. Okay? So you just set up that proportion, then you just cross multiply and solve. So for example here, let's do an example of converting, convert the degree measure to radians, okay, or vice versa. Okay, as an example here. So for example, 150 degrees is equal to how many radians? Ugh. You could use this first formula. We have 150 degrees, and we want to convert it to radians, so we'll multiply by pi over 180. So we could do it this way. 150 times pi over 180. Okay, so that's the first method there. We're taking a degree to a radian, so multiply by pi over 180. And that gives us then 150 pi over 180. What's down that fraction? We want to simplify that. So let's see, 150 and 180, that divides by 10. So you get 15 pi over 18. And then 15 and 18, we can both divide that by what? 3. So you get 5 pi over 6. Or you could use proportion. So in the proportion idea, I'd say something like, I don't know, let's use 180 degrees. That matches up to pi. And then that will equal, well, let's see here. In my proportion here, I did degrees over radians. So that means in this proportion over here, I have to do degrees over radians. The degree measure, I know that. It's 150 degrees. The radian measure, I don't know. I'll just call that x. Okay. So there's the other way to set up using a proportion. Degree and radian measure that you know, or radian and degree measure that you know, and then set up the equivalent proportion on the other side, equivalent ratio, sorry, on the other side. And we just cross multiply and solve here. So we get 180 x equals 150 pi, and then you finish solving for x by dividing both sides by 180. Which then you can simplify down to the 5 pi over 6. Okay, so you get the same answer. You get the same answer. Whatever you want to do to convert from degrees to radians, radians to degrees, that's up to you. I've showed you 2 here. I'll be using the proportion. Okay? I'll be using the proportion. Because again, in my mind, I think it makes the most sense because it comes right from the way that we developed. The idea that 180 and pi are in the same proportion, so then all these other ones should be in the same proportion too. Okay? Just multiplying by pi over 180 or multiplying by 180 over pi, it's kind of like Okay. So let me give you guys two to try here. So 300 degrees to how many radians? And then also, how many degrees gives us 7 pi over 6 radians? Okay. So go ahead and try those two. I'll kind of walk around and see if you have any questions. Actually, I'll zoom in a little bit there. Bless you. 30 more seconds here. 30 more seconds. Okay, so volunteers for the first one there. 300 degrees is how many radians? Out here, yeah, James?
5 pi over 3.
5 pi over 3. Very good, yep. 5 pi over 3. Okay. And then 7 pi over 6 radians is how many degrees? How many degrees is 7 pi over 6? Radians is how many degrees? Oh, let's go to Sean. 210. 210? Is that what you're going to say too, Nick?
Yeah.
210. Exactly right. All right. Any questions on any of that? Anyone want to see one of those done? Yeah, James? The second one?
Mm-hmm.
Okay. So, were you able to set this one up at all, or any idea, or you just kind of stuck, or?
I set it up, I just got stuck.
Okay, so we get 100. Did you do like 180 over pi, or did you do proportion?
180 over pi.
Okay, and then equals. And so now we don't know our degree measure, so we're going to put the x in the numerator, and the 7 pi over 6 will go in the denominator like that. Okay, so we still cross multiply here. Now it's going to be pi times x. So we get pi x equals, and that's going to be 180 times 7 pi over 6. So far, so good? Now, 180 is over 1, right? So to multiply this, it's going to be 180 times 7 pi, and then 1 times the 6. But before we multiply fractions, if you remember from like fraction arithmetic and stuff like that, we can simplify. So for example, that 180 and the 6 both can simplify some, right? So they divide both by 6. We're left with 30 here equals, well, there's 1 there. And then there it is. 30 times 7, 210. And you divide both sides by pi, and you get the x is 210 degrees. Okay? So that's all it is. All right. Any other questions on any of that? All right, so that's all I've got for you guys today. So I'll get you guys started on your assignment here so you can get some practice in. All right. Close this here.